The warm-up for today's lesson can be found on page 289. So if you're looking for that, navigate your way to page 289 in your workbook. Then we're going to start off with this lesson. It says, Logan says that a dilation maps figure A, B, C, D, E onto figure A prime, B prime, C prime, D prime, E prime. Do you agree with Logan? So if we were to connect corresponding points, for example, A with A prime, B with B prime, C with C prime, D with D prime, and E with E prime, we would be looking for one place where all the points intersect. But they don't all intersect at one location. So this may have a dilation, but it's not the only motion or transformation that occurred. So do we agree with Logan? No. I disagree. If this were a dilation, then we should be able to locate the center of dilation by connecting lines through corresponding vertices, but these do not all line up at a common point. For problems 2 through 7, we're going to flip a coin 2 times to create a sequence of transformations. After each coin flip, mark whether the coin lands on heads or tails. Circle the transformation in the first column, then for flip 2, circle it in the second column. Draw and label the point P under the following sequence of transformations. Alright, so flip 1, heads. Flip 2, tails. So to start, we're going to dilate from center O using a scale factor of 3. So you will want a ruler and a compass for this lesson because we're not dilating along a grid. So we're going to open our compass up to that distance between O and P. So there would be a scale factor of 1. 2 and 3. So here is P prime, and then we need to rotate 90 degrees counterclockwise around point O. So you're also going to need a protractor. So we're going to draw a straight line through O. Then line that up with our protractor, create a mark at 90, connect them, and then we'll use some tracing paper to rotate. So we're going to trace P prime, that line through O, and we're going to rotate counterclockwise, holding our pencil on O, until that line matches up with our mark for 90. And we're going to place it in its new location, labeling this P double prime. Moving on to question 3. Again, we're going to flip that coin Oops. Landed on heads. And tails again. So to start, we are going to translate along AB. So we'll extend the line through that vector. And we are moving ST. So we're going to trace the vector and the segment ST, and then we're going to slide along that vector until the end matches up with the point, and ensure that it is on the line that we extended. Then we are going to place it in its new location, labeling it with S prime T prime. And connect it with a straight edge. Then our second piece is to dilate from center O with a scale factor of 1/3. So we're going to draw lines through center O. And we're going to measure that distance and split it in thirds. So I'm going to use probably my centimeter side. This appears to be around 3.3 centimeters, so a third of that would be 1.1. So I'm going to place a dot here for T double prime. Then for O to S prime, that appears to be about 2.2. And if we do a third of 2.2, that is approximately 0.73 repeating. So we're going to go to 0.7 on our ruler and put a dot for S double prime and connect those. If you had a different sequence, yours may end up in a different location. We'll begin by flipping the coin for number 4. Tails. And tails again. So we're going to start by dilating from O using a scale factor of 3. So we will dilate A by a scale factor of 3. So there's 1, 2, 3. Then B, there's 1, 2, 3. C, 1, 2, 3. Hope it got smushed a little bit. Try that again. 1, 2, 3. And then D, 1, 2, 3. Connect them using your straight edge. So we've got this shape here. Then we're going to reflect across line N, which is this one here. So we're going to trace A prime, B prime, C prime, D prime, and the end of line at N. I'm going to put this little mark here just so I can line it up there as well. And we're reflecting across line N, so the end point should be here, and then that little mark should be in the corner where they cross. Trace back over it to help us see where it is in its new location. And then use a straight edge. This would be A double prime, B double prime, D double prime, C double prime. Now we have a grid, so this will help us. We won't have to do as much with the tools that we have here because we have the grid. So we're going to flip tails, and tails again. Alright, so we're translating 5 units down. So from here, go 5 down. 1, 2, 3, 4, 5, and 1 unit left. So here is A prime. Then we are going to dilate from the origin with a scale factor of 2. So if we're dilating from the origin, that rule says that we can multiply the coordinates of A prime by 2. So negative 4 times 2 is going to be negative 8, and negative 2 times 2 is negative 4. So negative 8, negative 4. On a grid, it's a lot more efficient. Six. That one didn't even flip. There we go. Heads. And heads again. Alright, so we're dilating from the origin with a scale factor of 5/4. So we're going to take A, B, C, their coordinates, and multiply by 5/4. So we have A is at negative 8, positive 4. B is at negative 4, positive 8. And C is at 0, positive 8. So we're multiplying by 5/4. 8 times 5, or negative 8 times 5, is negative 40, and negative 40 divided by 4 is negative 10. 4 times 5 is 20, 20 divided by 4 is 5. Negative 4 times 5 is negative 20, divided by 4 is negative 5. 8 times 5 is 40, divided by 4 is 10. 0 times 5/4 is just 0. And 8 times 5/4 we just did came out to 10. So we're going to plot those points using A prime, B prime, and C prime. Then we're going to plot these for B prime and C prime. We'll connect them using our straight edge. And then it says to reflect across the x-axis. When you reflect across the x-axis, the x-coordinate stays the same, but the y-coordinate changes to its opposite. So the negative 10 stays the same, but the 5 becomes the opposite. Opposite of 10 is negative 10. Opposite of 10 is negative 10. So we have negative 10, negative 5 is going to be a double prime. Negative 5, negative 10 is going to be B double prime. And 0, negative 10 is going to be C double prime. Number 7. Tails. And tails. A 90-degree counterclockwise rotation about the origin, followed by a dilation with a scale factor of 0.5. The nice thing about this is the axes create a 90-degree angle for us. So we're just going to trace this little line through the origin. We are going counterclockwise, 90 degrees. We're going to plot those in their new location. Connect them with the straight edge. So this is A prime, B prime, C prime, D prime. And we're dilating by a scale factor of 1/2. So A prime is at the origin, B prime is at 2, negative 4, C prime is at 6, negative 6, D prime is at 6, 6, negative 2. And we're multiplying by 1/2. Half of 0 is just 0, so this one's going to stay at 0, 0. So this is A prime, A, and A double prime. Then half of 2 is 1, half of negative 4 is negative 2. This is now B double prime. Half of 6 is 3, half of negative 6 is negative 3. Half of negative 2 is negative 1. So we have 3, negative 3, 3, negative 1. And again, connect them using a straight edge. So we got this little shape here as our scale factor of 1/2. Number 8, consider the segment XY, point O, and the vector AB. Draw and label the image of XY under the following sequence of transformations. First, a translation along AB. Start by drawing the line through the vector. You're going to trace XY and the vector AB. Slide it up until the end matches the point and place it in its new location, labeled with X prime, Y prime. Then dilate from O using a scale factor of 3. So we're going to draw lines connecting O and X prime, O and Y prime. Grab your compass, open it from O to X. 1, 2, 3. This will be X double prime. Then working with Y. Two, 3. And connect them. B. Locate the center of dilation for the single dilation that maps the original to X double prime, Y double prime. So if we were to connect X to X double prime, we're looking for a place where those lines intersect to find the center of dilation if it was just at one dilation. And so here we would have that center of dilation, and it says to label it with point P. What is the scale factor of the dilation with P that maps XY onto X double prime, Y double prime? So if we were to measure, this distance here is right at around 2 centimeters, and this one is at about 6.5. So the new divided by the original. We can also verify over here. This distance is about 1.5. And this distance is approximately 5 centimeters. So when we divide, 6.5 divided by 2 is 3.25. 5 divided by 1.5 is about 3.3 repeating. So our scale factor from P is around 3.3. It's in between these two. Again, remember that the there's some error just based on how perfect we can get our compass and our measurements here, but it's between 3.25 and 3.3, so we can approximate it, or 3.3 repeating, so we can approximate it as our scale factor is around 3.3. Now, ideally, it should come out to exactly 3, because what happens is we translated this, so it should stay the same size, and then we scaled it by 3. So it should be exactly 3, but remember there's some error in here based on just our calculations. So the scale factor should come out to 3 because this should be the exact same size as this piece, and we dilated it by a scale factor of 3. So in a perfect world, 3. In reality, we got pretty close. Number 9. Draw and label M and O under the following sequence. Dilate by a scale factor of 1/2 from center O, and then translate along AB. So if we're dilating from O, it's already got lines connecting M and N to O. So this appears to be about 2.6. Half of 2.6 would be about 1.3. To N, we're at about 6.4, so half of that would be 3.2. And then we'll connect those. Then we're going to translate along AB. So we're taking this little triangle and translating it along this vector. Begin by extending the line through the vector. So we will take our triangle And we will trace our vector, sliding along that extended line until the end matches up with the point, and place your points in their new location. Oh, I got in the wrong spot. Okay, then we will connect them using the straight edge. It says locate the center of dilation for a single dilation from M in O to M double prime N double prime O double prime. So we're connecting the original point M with M double prime, the original point N with N double prime, and O through O double prime. Locate that center and label it P. So it appears there's a point in this vicinity. Again, it wasn't perfectly lined up. Again, there are some error in just where we place our points, but it should converge through this section. And it says, what is the scale factor of this dilation from P that maps M and O into M double prime, N double prime, O double prime? This original was reduced or shrunk by half, and then it was moved. So this one should still be half the size of this one. And if we use our compass, remember we're talking in a perfect scenario, if we did everything exactly precise, we should be able to just move it twice. So from P to N, that would be half the distance. So the scale factor would be 1/2. Now if we actually measured, it might come out slightly less than 0.5 or slightly more than 0.5, but in the ideal scenario, it should come out to about 0.5. That is it for this lesson. Please make sure that your warm-ups are finished. That was on page 289. Page 289 for your warm-up. The rest of it should be right here in lesson 10.